Topic 1.5, the Pythagorean Theorem. We can use the properties of a right triangle to find the length of a line segment. A right triangle has two sides that form the right angle. These are called the legs of the triangle. The third side of the right triangle is called the hypotenuse, and it can be identified because it is opposite the right angle. Okay? Hypotenuse is always across from the right angle. The other two sides of the right triangle are called the legs. Here is a right triangle with squares drawn on each side. Notice that the area of the square on the hypotenuse, which is this yellow one, is equal to the sum of the areas of the squares on the two legs. So this red one and this blue one. Now, this is always true for right triangles, and this relationship is called the Pythagorean Theorem. So for any given right triangle, if you drew squares on each of the three sides, the area of the two smaller sides, the two legs, will always be able to add up to equal the area on the hypotenuse. We can use this relationship to find the length of any side of a right triangle when we know the lengths of the other two sides. So when we know two of these side lengths, we can use this relationship to determine the third side length. The theorem is expressed like this: a squared plus b squared is equal to c squared, where a is the length of one of the legs of the right triangle, b is the length of the other leg of the right triangle, and c is the length of the hypotenuse. Let's have a look at a couple of examples. Let's say we're given a right triangle, and we know that the length of this leg is 3, and the length of this leg is 4. But we don't know the length of the hypotenuse. We can use the Pythagorean theorem to solve for this missing side length. The Pythagorean theorem states that a squared plus b squared is equal to c squared. In other words, the square on one of the legs plus the square on the other leg will always equal the square on the largest side, which is known as the hypotenuse. Okay? Now, it doesn't really matter which leg is A and which leg is B. If you solve it both ways, you'll find that it actually turns out to give you the same answer. So I'm just going to label this one as A, and this one as B, and I'm going to plug in these values into our formula, and I'm going to solve for C. Now C is always the hypotenuse, so just be careful when you're working with Pythagorean theorem that you always put the hypotenuse over here on its own. The two smaller squares will always add up to equal the largest square, which will always be on the hypotenuse. So I'm just going to plug this number in. This would be 4 squared plus 3 squared. This is going to equal the square on side C. Then I'm going to continue to solve the problem. 4 squared is 16. 3 squared is 9. Okay, this is equal to c squared. And then I'm going to add these two values up. So 25 is equal to c squared. In other words, the area of this square over here is 25 square units. Now, we're interested in the side length here of that square, right? And in order to find that, we need to recall that the side length of any square is equal to the square root of that square's area. So if we have the area, we just need to determine its square root, and we've got the side length. So in this case, the area is 25, so our side length is 5. So the value of C is 5. we can follow that same procedure to solve for the missing length of any right triangle, as long as we have two of them. So let's say we have another right triangle, and this time we know the length of the hypotenuse, which is across from the right angle. Let's say we know that that is 10. And we know that the leg on the bottom of this right triangle has a length of 6. We can use the Pythagorean theorem to figure out the missing leg. And let's call it A. Remember that the legs are A and B. So let's remember our theorem. A squared plus B squared is equal to C squared. So the square on leg A plus the square on leg B will always equal the square on leg C. And C is always the longest side of a right triangle, which is, in this case, 10. So I'm just going to plug in the values that I know, and then we'll solve it. So we don't know what A is. We do know that A squared plus B squared is going to equal C squared. We know what B is. B can be this number 6. And we know what C is. C is 10. Okay? So now we just continue to solve what we do know. We still don't know what A is. 6 squared, we can figure out. 6 times 6 is 36. 10 squared is 100. 10 times 10 is 100. Okay? So now we have this as an equation. A squared plus 36 is equal to 100. Now whenever you have an equation like this, what you want to do is isolate the variable that you want to find. Okay? In this case it's A. So we want to get this on its own over here. How do we get it on its own? We need to remove the 36 from this side. Okay, that is going to give us 0 over here. And we can cross out the number 36. Now, whenever we have an equation, whatever we do to one side, we have to do to the other side. So what I'm going to do is subtract 36 from the other side to keep things fair and balanced on both sides of the equal sign. So that's going to leave me with 64. Now I can rewrite this equation now as A squared is equal to 64. In other words, the square on leg A has an area that equals 64. Now we have one final step, and that is to determine the side length of that square. So the side length of any square is equal to the square root of its area. We know that the area is 64, which means that that length is 8. There you have the Pythagorean theorem.